This is part 3 of the sampler looper Loopstation tutorial. So this time, last time we worked on recording. This time we will work on the playback engine here in SuperCollider. And it's very similar to the record one we made. So let's go ahead and create a synth def. Maybe make this a little bit bigger. Synth def. And we'll call this buff play. Okay, and then just set up our open synth-def.add. All right, and we're going to use a very similar ugen here called buff play. All right, but unlike the buff write, where we're just calling the ugen because it's writing to a buffer. We're going to have to stick it in an out because the playback is actually going out to our speakers. So we'll use the out ugen.ar audio rate, and the thing we'll send out is, we'll just call it our signal. Okay, or which bus? Well, I'm going to put 0 here, but in fact you can change what channel you play it out. So why don't we give that a variable name? We'll say OCH, out channel, and then we'll make a variable called sig. We'll send it out signal. So let's go and create those so we don't forget about that. We're going to have an argument called OCH, and it's going to have a default of 0. So that's our out channel. We'll just stick it out to channel 0 on default, and then, but you can also change that in case you want to play a multi-channel sampler. You can play out different speakers. Then we have our var, and we're going to call that sig. Let's go ahead and create the signal. SIG equals, this time we're going to use the ugen buff read rd.ar. Okay, and it says the number of channels where we just have one. We'll just hard code that. You could make a stereo one or et cetera, but we'll just hard code this since we're presuming a single mic. And the buff number, we'll make that an argument. We'll just call it buff. And then the phase, again, we're going to have exactly the same as we did with the buff record. Remember, we went through the trouble of having sort of an external index, this index, buff index synth def. And we're just going to read that from the bus. We're going to read that from it's sending it out an audio bus, and we'll just read it from there. So our phase is going to be, here we called it index, IDX. Okay, and then the loop and interpolation will leave as the defaults. All right, so what did we create? We created an argument buffer, and that will be given on when we create a synth, because we don't know which buffer yet, so we won't have a default. And then we'll have an index, which will be a variable, and it's much like what's going on here. So what we'll have is, we'll have the index be in from an audio bus. So IDX, we use the in ugen, in.ar, and we're going to choose a private bus. Remember, we have these private audio buses that can come in, so we'll call it IDX bus. And we'll just go ahead and again, we'll create some buses up there, and we'll just, when we instantiate it, we'll let them know which bus it's coming in. So we'll have IDX bus. And then so great, yeah. Yeah, so we have our index bus, and that's going to read, and then our signal, which is the reading the buffer, will go out. So we're pretty much all the way there. We're just going to create an envelope as well, so that we avoid sort of clipping, and it'll be a good way to start and stop these synths. So we're going to do the same thing we did with the buff record. We'll have an env equals mgen.ar, and it's going to be an envelope. And we're going to use the ASR type. And we'll have a release time. Again, we'll just keep the tag time. And we'll make that 0.01 as well, the release. And we'll just make a curve. And make it 0. Okay. And then we'll have a gate. And then we'll have a done action 2. And just to review what all those things are, I created an envelope using this ASR shape. attack, sustain, release. And I use these labels because I'm skipping, as you can see, skipping the first arguments. So I'm just skipping over to release time because we want to keep the default sustain level of 1, attack time of 0.01. So I have a release time of 0.1 in the curve. So really it's just to avoid the little clips or if we play it right away, sometimes if there's no envelope, it'll click a little bit. So that's our envelope. It's just something when we play. And our gate is to start the envelope and end the envelope. So we'll start it when we want to play, and when we're done playing it, we'll just kill it. And that's what this done action is. When gate becomes 0, it ends the envelope, and once the envelope is end, its done action is 2, which means kill the synth that it's in. Okay? And just so I don't forget, I just want to make sure I multiply that signal by the envelope so that it's actually being used. Okay? So that's pretty much our buff play object. My cheat sheet to see that I call it buff PL. I'll go ahead and change that pretty much. And then I changed this gate sort of metaphor. So we'll make it buff PL then, maybe. And then I will change, let's see, I will change the, I need to add a gate, right? And it's default to 1, right? So it's going to be on as soon as we instantiate it. It'll be created, and then when we release the envelope, it'll be killed. So we can do that every time. Hopefully that ends up being a good way to go. Okay, so great. So let's go ahead and do a little thing. So we'll create a couple synths. These are just sort of practice ones because we're going to create some OSC messaging to get it going. So we'll create, we have a buff index, we have a buff record. We'll make a buff equals synth. We'll make a buff play then. PL. And then we have some arguments. We need the buffer. All right, so now we need a play buff. So it's going to be recording into this buffer, which is one and the same. So we're recording and we're playing from the same buffer, right? It's the sound buffer. We're going to record into that buffer, and then we're going to play back what we just recorded. So it's going to be the same buffer, right? So then our argument for buff will be this buffer that we've created up there. Okay. And then our index bus will be the same too, because we want it to read from the same place it's recording. I mean, we can change that, but yes, it's still going to be an IXA bus. Okay. Oh, right. All right, audio bus, right? Then that's right. Okay. So then that's the playback. We have a buff, we have an index bus. Our gate's already preset to 1. And our out channel is already preset to 0, so we'll just keep those the defaults. Now, remember, we have this group situation. So remember, just as a quick review, the groups are to deal with more the data side, the programming side, the way the computer functions, not so much to do with audio, even though it's using sort of a similar kind of ins and outs metaphor. So we have the index group, which means that our index buffer is going to be executed first, right? So that we have that index, because since both these, the recording and play guys, are depending on the index to drive them, in this phase, where is it? This phase argument there, and then we have a in group. All our ins or record is going to go to that group. And so we want to make sure we play back after our recording, right? So we record first and then play back after, so that we play back what we have recorded. So our out group, and I think that's what I call it the OGR. The OGR is going to be a group dot after, and then it's going to be after the in group. INGR, okay? So we got to just make sure that programmatically, data-wise, it order of execution. Executes the index first, so we have that to use. It executes the record first, so we can play back after we record. All right? And then, so just when we create our synth, remember there's these three areas of arguments. The first argument is the name of the synth def we want to use. The second argument is really one argument, but it's an array. It's a set of arguments and values of the actual synth def. So this buff belonging to this synth def here, index bus belonging there. So those are the arguments of the synth def in these square brackets, which is an array. So that's our second argument. And then our third argument is the target or the group we want to set it onto so that there's an order of execution. And I call that the OGR, right? And then a bracket to, or parentheses to end. And there we go. We have our C synth. Okay. And then we want to be done recording. We set our B, that's our record synth, to 0. So we'll do the same thing for the C. C, which is our play synth, we want to be done playing. Do SET gate to 0, I'm sorry. Okay, now the only thing about the play synth is that this will kill it. Remember, it's a done action 2, so that means it'll go away. So we have to restart the play synth if we want to play it again or continue to play. Okay, so let's go ahead and see what happens here. I'm going to save that, and I'm going to boot my server and then send all these variables out to Super Collider, and then also my synth desk. I could have done all that at the same time. Okay, and then I'll create my 3 synths. Now, as soon as I'll start my index synth. As soon as I start recording, it'll record. So we'll just do these one at a time. So I'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, and then that's done recording. And let's see the playback, if we can get it to sound. So I'll go 1, 2, 3, 4, 5, 6, 7, okay, there 8, you go. 9, 10, 11. Okay, and then to stop it there. Great, and then I'll stop the playing. Okay, so there you go. The playback part of our sampler looper is very similar to the record part. We instead, a few differences. We have to send it out to the speakers. We use the out UGen. And just remember that we're using envelopes to kill it after it's done. We're using this index, this in from an audio bus to drive our read head, really, our play head. All right. And then here we added a out group there so that, data-wise, order of operations-wise, the play is after the record. Okay, well, let's wrap that up. That was a little shorter one. And the next time we're going to look at, I think, we'll start to look at ways of the OSC defs, ways of sending messages to start recording and such. Right. Okay, well, there's lots to do, so there'll be a lot of these. But yeah, we'll start looking, or maybe we'll hit the GUI. Well, I'll decide next time. Okay, well, good luck with that. Hope that goes well.